Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engaged New York Math, Module 3, Lesson 7, Ordering Integers and Other Rational Numbers. When we talk about ordering, we're simply saying we're putting the numbers in order, and that might be from least to greatest, and it could also be from greatest greatest to least. That's what I get for writing and talking at the same time. All right, let's get started. Okay, first up, a little warm-up. It says graph the number 7 and its opposite on the number line. Graph the number 5 and its opposite on the number line as well. All right, well, the number 7 we see is right over here. The opposite of 7, as we already know, is going to be -7. They're both 7 away from 0. Graph the number 5. Well, it's 5. That's a positive 5, so that's 5 over to the right of 0. -5 is the opposite because it's 5 to the left of 0. Question B, where does 7 lie in relation to number 5 on the number line? Well, 7 and 5, 7 is 2 to the right of 5, right? So 7 is, of course, larger. Where does the opposite of 7 lie on the number line in relation to the opposite of 5? Well, 7 in this case, -7, which is the opposite of 7, is 2 to the left of -5, which is the opposite of 5. So we can see that 7 is larger than 5, but -5 is larger than -7, because, of course, as we go to the right, we get larger. As we go to the left, we get smaller. Okay, question D says, I'm thinking of two numbers. The first number lies to the right of the second number on a number line. What can you say about the location of their opposites? Well, in this case, if the numbers, and let's go back up here, let's say the number you chose, you could pick any number at random, right? But we could say, let's say 2, because it says it's thinking two numbers, and let's say 10. We know that looking at these two numbers, the number on the right is going to be larger. And same thing, if we instead had chose, let's say, -10 and -3, -3 is still larger. So the number on the right, the farther to the right you go on the number line, whether you're in positive or negative integers or rational numbers, as you go right on the number line, you're getting bigger. Okay, let's go through some examples here. Example 1. The record low temperatures for a town in Maine are -20 degrees Fahrenheit for January and -19 Fahrenheit for February. Order the numbers from least to greatest. I'm going to highlight that because that's important. Explain how we got to that order. Now, I was going to use a number line. In this case, because we're talking about temperature, and most thermometers you might see would go vertically as opposed to horizontally, I'm going to create my number line here. So I'm going to go 0, -5, -10, -15, -20, and I know that -19 would be somewhere about right here. Okay, so as I look at this from least to greatest, well, numbers get smaller the farther you go. If we had done this on a number line like this, I'm not going to write them all, but we'd have -20, -19, right? Numbers get larger as you go to the right. They get smaller as you go to the left. So when we say least, -20 degrees would be colder than -19. So -19 would be warmer than -20. Now, obviously, not so much that we would even notice it, but least to greatest, we're going -20 degrees, then -19 degrees, in that order. Okay, second question here. John's time for running the mile in gym class is 9.2 minutes. Jackie's time is 9.18 minutes, or 9 and 1800ths minutes. Who ran the mile in less time? Well, here's another example where I'm going to create a number line. Start at 0. Actually, since both of these times are in between 9 and 10, I'm going to go from 9 to 10, and I'm going to say 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 9.8, 9.9. I won't label all those. We don't even need it. If we come down here, we know 9.2 is going to be right here. 9.2, which is John's time. We also know that Jackie's time is 9.18. So 9.18 would be between 9.1 and 9.2. So Jackie's time would be about right here. Jackie. Geez, that kind of goofy. Jackie. So who wrote or who ran the mile in less time? Well, that would be Jackie, because she ran it in, he or she ran it in 9.18 minutes. Another way you can look at this numerically, we just want to look at it in terms of numbers. John went 9.2. If I want to compare that to Jackie, Jackie went 9.18. I've lined up, you'll see, the ones place, the decimal, the tenths place, and the hundredths place. Now you may notice that John's time doesn't have a hundredths place. If that's the case, we have 9.2. We don't have a hundredths place, so we can fill that in. I keep doing that as 0. And so 9.20, 9.18, right? The 9s are the same. We have our decimal in the same spot. The 1 of Jackie's time is less than the 2 of John's time, so that's as far as you need to go. But if you want to see it and look at it almost in terms of, you know, who has less money, think about it now. Someone who has $9.20, someone who has $9.18. Well, of course, that would be Jackie. Okay, similar problem, but in this case, we're looking at negative times. Henry, Janon, and Clark are playing another round of the card game. Their scores are: Clark is -1, Janon is -2, Henry is -4. The person with the highest score wins. Well, so who won? Well, if we're going to create our number line, they're all below 0, right? So we have -1, -2, -3, -4, -5. We don't even really need it. But Clark was at -1. We'll put him here. Janon was at -2. Put Janon here. Henry was at -4. Put Henry here. Well, if numbers get larger as they go to the right, the largest number is Clark. So Clark won. Who was in last place? Well, Henry was -4, so Henry was in last place, and then Janon was in second place. What if we had another player, we'll say Billy, whose score was 0? Would Billy have won? Well, if we chart that over here, again, numbers going to the right get larger. 0 is actually larger than -1. So even though it seems silly that, well, he scored 0 and he won, that would be the case. 0 is higher than -1. Think about it this way. You'd rather have money in your pocket, don't get me wrong, but if you only had the choice of having $0 in your pocket, or you have no money and you owe someone $1, which would you rather have? Well, you'd rather have no money instead of having to owe someone $1, right? Okay, one more example here. This says, represent each of the following elevations using a rational number, then order them from least to greatest. Well, this lake here, Cayuga Lake, 122 meters above sea level. Above would tell us that's positive. We go 122. Mount Marcy, 1,629 meters above sea level. Again, above, 1,629 positive. And then the New York Stock Exchange Vault, 15.24 meters below. Below is our key word, so that would be represented as -15.24. If we were to label these in order from least to greatest, the smallest one would be -15.24, because it's the only number that's less than 0. 122, and then 1,629. Okay, those are all the examples we're going to go through today, but we will look at some more examples in class. There's my dog freaking out. We'll look at some more examples in class together. Thank you for watching.